Welcome to helpyourmath.com. In today's video we're going to be using completing the square. And there's different ways you could use completing the square, but in this first video what we're going to do is we're going to see how to use completing the square to solve for x. Now when you're solving for x, it takes a huge load off of your shoulders because the work is kind of a lot easier to transition through. Alright? So in the first problem here we see we have x squared plus 6x's equals 0. Now to complete the square to solve for x, this makes our life a lot easier because there's no constant term on the left side of the equation or the right. It's equivalent to 0. So this makes the process pretty simple. In the first case, what we always want to do when completing a square, whether or not we have that constant, is we want to factor out the coefficient of the x squared term. In this case, it has no x squared coefficient, which makes our lives a lot easier. And what we're going to do then is just take half of the middle term, the coefficient of the middle term, which is 6 in this case, a positive 6, and we're going to add the square value of half of the middle term to both sides. And what we do then is we take the original equation and we're going to add half of the middle term. In this case, we're going to take the positive sign with the 6 because it's really important what happens with the symbol inside the parentheses here. And we're going to do the same to the other side now. So we're adding half of the middle term squared. And I brought the plus over here just to make your lives a lot simpler to transition to understanding this. The next step we're going to take is just simplifying what we have inside the parentheses. So we have x squared plus 6x's plus a positive 3 being squared is equivalent to 0 plus, again, a positive 3 being squared. And now what we're going to do in this step is we're going to complete the square on the left-hand side. So what we're going to do to complete the square is we're just going to take the term that's being squared and place it in the parentheses. And we know on the left-hand side we have just an x. On the right hand of this equation we have a positive 3. So we're going to bring the sign with the term into the parentheses. Then we're going to continue to square the term because this makes the perfect completed square where we have a squared plus 2a times b plus b squared. And we see a is x and b is just 3. So 2 times 3 times x is 6x's, and we know we completed the square properly. Now on the right hand side here we have 0 plus 3 squared is 9. No matter the sign on this, is always going to be a positive 9. So now we have our completed square. And to use the completed square to solve for x becomes pretty straightforward. Now whenever we have a term being squared on the left for a single variable and on the right, what we're going to do is we're going to take the square root of both sides. So on this side we have x plus 3 being squared is equivalent to, and whenever we take the square root of a constant term, we know that if this were a positive 3 or a negative 3, it would have created the same 9. So we want our square root to reflect the same thing. Now the square root of a perfect square is just the inside, which is just a perfect square. And this is equivalent to plus or minus the value of 3. And now what we want to do is we want to take both cases into account. So when we have a positive 3 and a negative 3, we're going to get two different results. So when 3 is positive, we have x plus 3 is equivalent to a positive 3. We move the 3 over. And here we get our first solution, x equals 0. In our second condition, this is going to be a negative 3. So we have x plus 3 is equivalent to negative 3. And we subtract 3 to both sides again, in which we get x is equivalent to negative 6. Now here we have the two solutions for completing a square, and here we could just list them. x1 equals 0, x2 equals negative 6. And we have our first set of solutions for this problem. Now let's move on to a more complex one where we see we have a constant on the left-hand side of the equation. And we'll begin doing the same process, all right? So let me just wipe this down 1 second. Here we begin again. So now we have x squared plus 4x's minus 1 is equivalent to 0. And in this case, since we have that constant, the first thing we want to do when we're starting this problem off is we want to move that constant term over so that we have the same form of an equation we did in the first case of this problem. And we'll just add 1 to both sides to do that. Transposing the 1 from the left to the right. Now we have x squared plus 4x's are equivalent to 1. And again, we're going to complete the square by first determining if there's a coefficient. In this case, there is none again. Makes our life a lot easier. And we're going to take half the middle term and we're going to add it to both sides of the equation. The middle term in this case is x plus 4x's, positive 4x's. So we're going to add a positive 4 divided by 2 squared to both sides. Next step, we simplify, and what we get here is x squared plus 4x's plus a positive 2 squared is equivalent to 1 plus a positive 2 being squared again. Now, what we want to do next is complete the square on the left-hand side, in which we get x plus the positive 2 here, right? And the plus, again, it's plus because of the positive 2 that we get when we divide the positive 4. And this is equivalent to the right-hand side, which is 1 plus another positive 4. Therefore, when we simplify the right-hand side, we get a positive 5. And now we're going to do the same thing as we did in the last problem. We're going to take the square root of both sides, considering that this becomes a plus and minus square root of 5. And we're also going to square root the left-hand side. So let's just do this side first. And we're going to get a positive or negative square root of 5 on the right. The square root of x plus 2 perfectly squared is just x plus 2. This is equivalent to plus or minus the square root of 5. And again, we get two possible scenarios. When we have a positive term for the radical 5, we're going to get x plus 2 is equivalent to radical 5. When we subtract the 2 to both sides, these go away, and this gives us x. The negative 2 will proceed, and the positive 5 will go second. The positive radical 5. And this is for the form of a plus bi, right? Or the square root of a term in complex form. So here's our first solution. Our second solution is when the radical 5 is a negative. So we have x plus 2 is equivalent to the negative square root of 5. And finally, we just subtract that 2. And again, these are not like terms, so we just leave it as x equals negative 2 minus the square root of 5. And there we have our next two solutions for this problem, where the first one is x equals negative 2 plus the square root of 5. And finally, we have its conjugate pair, which is equivalent to negative 2 minus radical 5. All right.